Make sure there's no echo.
Okay, we are having. Hello, everybody. I can see many participants joining. Quickly, we have gone to 55, 60. We'll wait for about a minute or two before we start this. For people who have already joined, welcome to this webinar. I'm so glad that you are able to make it at such short notice. But I wanted to make sure that, if people have any questions about the competition, they are able to ask live here. So um, the format is going to be, we are going to show a quick demo of Oak so that people understand what are the capabilities of this device, Oak D. Um, and because it will also help if you're not familiar with Oak D, it will help you understand what it is capable of doing, and that will help you write a good proposal. So that's the first 20 minutes, and the next 25 minutes we will answer any questions you have, and you can ask your questions by pressing that Q&A button at the bottom of your screen. So yeah, I'm so glad to that you guys have made it. Right now, we have about 138 people, 39 people joining this. So let's wait for another 1 minute, and we will get started. Or actually, we can start by short introductions about ourselves, so that people don't miss the demo. So a short introduction about myself. I'm Satya Malik, and I'm the CEO of OpenCV.org. I have been in this role for a little over a year, almost 1.5 years. And one of the goals at OpenCV for that we envision is, for the last 20 years, OpenCV was the library, the OpenCV library, but we are growing beyond the library. Since I took over, we started with OpenCV courses, which help people, get an education in AI. And then we did OpenCV AI Kit with Brandon and his team. The goal is to expand the scope of OpenCV. We want people to come to OpenCV for anything related to computer vision, any questions related to computer vision. So it is growing much beyond the library. The library is still our flagship product, but we are growing. We are doing courses. We are doing webinars. We also opened up OpenCV Forum, the new forum, which will allow people to ask questions about anything related to computer vision. So all these things are happening. I don't want to take up all the time. And with that, I want to introduce Brandon Gilles, who is the chief architect of Oak. I want Brandon, could you introduce yourself?
Yeah, absolutely. Hi, guys. So I'm the chief architect of Oak and the CEO of Lexonis, so the OpenCV AI kit, which I'll unbox here. It's funny to see it backwards on your own screen, actually. So our mission is to materially improve the engineering efficiency of the world, which is a huge goal. So we sought out on this mission because we were trying to build a product that required embedded performance spatial AI and CV, and there was no way to do it. You could do it with a whole computer, you could do it with a whole bunch of things combined together, like depth cameras and CPUs and GPUs and stuff, but you couldn't, actually just embed it. So we built Oak, which allows you to do embedded. So you have it's a modular design, so you can embed this into your drop test own products. You can also just plug this into a computer and use it. And once you prototype, then you can embed this and have it communicate with ESP32. So it gives you capability to embed it. It's performant. You can run 12 megapixel at 60 frames a second. Actually, we have a variant coming out that has 20 megapixel 1-inch camera. It gives you spatial perception. So there's 1280 by 800 pixel depth sensing. So you get 1 megapixel depth map. And if you compare that to LiDAR, which is like 0.06 megapixel. So you actually get quite a bit of information. So you've got a 12 megapixel camera and then 1 megapixel depth map. And then it allows you to run AI as well. So you can run tiny YOLO v3 at 30 frames a second while doing depth perception. And then it has a bunch of accelerated CV. So depth perception is just one. There's motion estimation and all sorts of other interesting things. Optical flow, for example, is coming out soon. That's all hardware accelerated. So the Myriad X that's core to this, which is what we wanted to simplify the application of and the use in all these ways, has like 26 different accelerated CV functions in there as well. So that's the background on what we're doing. Our mission is to make it so you can actually productize something that you need to embed, that's performance, so you can run real-time AI, for example, spatial sensing, so you can have human level perception effectively on an embedded device. And it has the AI accelerators. So there's a dual core neural compute engine in here, and it has a bunch of CV functions, because often when you're solving these real world problems, you need accelerated CV as well. So that's a quick background on what we're doing.
Great, thanks. Next, I would like to introduce Ray. Ray is with Intel. He is OpenVINO's Edge AI evangelist. So if you have any questions about OpenVINO, Ray is there to help you. Ray, could you introduce yourself?
Great. Well, thank you for the introduction. So again, actually, I get a computer science background and computer engineering background. And right now I'm at Intel, actually helping a lot of people to onboard OpenVINO. And as you see from Brandon, it's actually one of those amazing product have the Intel chips built in. And my role here is actually to support a lot of the software effort, like the integration. For example, when you have an idea of creating a model, how can we deploy it on, let's say, an oak, right? One of these kits. And then if you have any problem, for example, on how that works, our Intel team, for example, uh, I'll say globally can help you to answer some of the question on, for example, how do you create a pre-trained model efficiently, and does it support correctly, and things like that. And I also get star background, so I really love to talk to some of your participants because I built augmented reality headset in the past, and really felt the pain. And this is a huge painkiller or vitamins or whatever it is to get away from a lot of pain I had in the past. So Brandon and I had a great talk. I'm so glad to see this today. And I have this. I'm advertising already. See, I'm literally an advocate and really love this kind of tool to can help developer to lower the barrier of entry to build any many of the AI kind of like prototypes.
That's great. And we also have Phil Nelson, who is the creative and content manager at OpenCV. And he ran our Kickstarter campaign as well for OpenCV AI Kit. Um, I don't know whether Phil is muted right now, but feel free to jump in and introduce yourself if you're there, Phil. He might have gone to get some coffee. So we'll come back. So Brandon, the format, like I mentioned, was that we are going to first do a demo where Brandon will show you all the various capabilities of what Oak is capable of doing, so that you get an idea how you can use an Oak for solving problems in case you're not familiar with the device. And then, so that would be about 20 minutes. And then we will spend the next 25 minutes answering any questions you have. And please feel free to answer, send the questions to the Q&A section of this chat so that we are able to answer them efficiently. Brandon, take
Great.
over, please.
Yeah, so I'll show the Oak D today, and I can't help but answering some of the questions now. So it pulls at absolute maximum 5 watts, and one of the advantages is it's fully factory calibrated on all 3 cameras. So the intrinsics are actually written to an onboard EEPROM that allow you to get actually just rectified streams out, so you can do your own things with rectified streams if you want, or just that's used internally by the hardware engine. So with that, I've got one here, and then one's tucked on my desk, kind of pointed at me with our tripod accessory, actually. So I'll share, first off, just a window it's running. This is a 2-stage neural inference, so you'll probably see like a big version of me. So it says neutral if I point this more at myself than as neutral. if I smile, I think I'm bad at looking angry, especially when I'm doing something like this. So it's neutral to happy right now. I don't know if it'll give me a sad because I'm actually smiling. So this is an example of doing face detection. Go ahead.
Brandon, we are not seeing your other screen. I think it's showing the side view, and it's frozen
Oh, really?
on the Zoom call. Yeah.
Oh, okay. Let me try that again. I don't know if maybe Zoom has problems showing OpenCV windows. How about now? Can you guys see
Yeah.
now?
Now it's good.
Okay, cool. All right. So yeah, Zoom probably was upset that I moved the window. So you can see this is two-stage inference. And one of the key things here is, this is all running on the camera. So actually the overlay, the video, everything is totally unnecessary, right? It's purely for visualization. So in applications where you wanted to, detect a face or, authenticate or something like that, you can literally just get the metadata. So I'm moving around, it's giving the metadata, and then it's telling, my emotion. So then it shows happy. So this is one basic example. You're not using spatial data in this case. So I'll stop this one and run another. It's actually running a mode called stereo neural inference. So traditional depth cameras, you're only running, this one I'll share my whole screen actually, so you can see what's going on. Hopefully it's not too pixelated. Can you see that, Satya? You're muted, by the way. Ray, can you see it? Okay.
Yes.
Okay, sweet. Okay, so I'm just running the depth AI demo, and then I'm running a first stage on both the left and right cameras, so face detection, and then I'm running a second stage on both the right and left. That's based on the results of the first stage, and then there's some settings on how many resources to use. So hopefully you guys will be able to see this. So this is a 300 by 300 neural network. So this is an example of stereo neural inference. So you can actually see two different views of my face from the two different cameras running at 30 frames per second in parallel. So this is an example where instead of running disparity depth on a whole image, you can actually run the neural network twice on left and right, and then you can triangulate the results to get 3D information. So it looks a little small here. This is stereo neural inference. You can run all sorts of things in this way, which is kind of a new way to do spatial sensing. So a reason you'd want to do this, say if you're perceiving some object that's shiny or reflective, disparity depth can't deal with that because it's going to reflect to somewhere else in the world, and so you'll get the depth result of wherever that reflection is pointing. With stereo neural inference, as long as you've trained on that object, you'll still be able to locate it in 3D space. So what this is doing is face detection and then facial landmarks. So my eyes, nose, and the edge of my mouth. So another example, so that's stereo neural inference with two stages. Yep.
Brandon, I want to add one more thing. So when we in a lot of demo videos that we have out there, you will see that we are running neural networks on the main camera. There are three cameras. One is the RGB color camera, and then there is a stereo pair. So there are two cameras for doing stereo vision, for doing depth. So, but what Brandon's demo showed is that we do not need to use those side cameras only for stereo depth. We could actually run neural networks on the feed that we get from these two cameras as well. So that's something, it's very flexible in that sense that you could use the RGB camera, but you could also do neural inference on the stereo cameras. It's very capable that way.
Yeah, and that's a really good point. Go ahead.
And not only that, you could also use multiple neural networks. You can chain multiple neural networks to do multiple things. For example, in the demo that you showed, the picture was small, so you may not have seen everything, but it was running a face detector. And after that, the face detection box was being passed to a landmark detector, and it was running a landmark detector also. So there were two neural networks running in series, one after the other, and you can configure it in that way. Yeah, go ahead. Sorry.
Right, and so speaking to that flexibility, that was a great point. Thanks for bringing that up, Satya. You can run the neural net or all of the cameras. So this is an example where the neural inference is actually running on the RGB connection. Hopefully you guys can still see it. I just got a notification from Zoom that says my internet connection's unstable. So it's running it on, you can, okay, great. So it's running on the RGB, and then it's doing depth based on the grayscale. So as I move here, you can actually see, and then it's pulling the depth from the center. So if I stand up, so now I'm 1.7 meters, and as I get closer, so this is what is this one? So this is monocular object detection. So it's just choosing a camera, running object detection on that camera, and then fusing it with the stereo depth from the other cameras. So this is one of the many ways you could run this. Another thing that you can do here is actually use data from all three cameras to produce a much better depth map. So you can see there are holes when you do disparity depth based on matching and so forth. And there is a disparity confidence threshold you can adjust here, and then there'll be fewer holes. But in some cases with surfaces, disparity won't get a match, like a big blank wall, for example. So you could actually pull in the left, the right, and the RGB, feed that into a neural network that then fills in the holes. Like my black monitors over here have a hard time getting a disparity depth. So there's all sorts of interesting permutations of combining the computer vision functions, the neural inference functions, and then depth information that can be modularly pieced together. And these are just some quick examples of what you can do. So let's see. I'm trying to think if there's other good demos we should go over, or if we should take a break for questions, and then we could kind of demo based on questions.
Yeah, actually, there are a few questions that we can start answering, changing the format as we go. I think that's perfectly fine. Let's answer some of the questions that are I can see in the Q&A already. So the first question is, what is the minimum and the maximum depth the camera can reliably read?
That's a great question. So you can see actually on my desk, so there's a variety of different depth modes you can do. So actually I'll run a different depth. So right now this is doing full 1280 by 800, and it's a 7.5 centimeter baseline. So the minimum depth then, so as my hand gets,
sharing
oh
your
shoot,
screen.
Yeah, let me share again.
Yeah.
As my hand gets closer here, you can see the depth, it gets invalid because I'm getting closer than 0.7 meters. But let me stop that, and then I'll change the setting. So long story short, the shortest you can go is 19.6 centimeters, and it depends on the mode that you're running on. So we support subpixel, which allows you to do longer distance depth and higher granularity depth for, say, like plane detection. We support extended disparity, which cuts your minimum depth in half. So I'm going to do the mono resolution here as half the resolution to give an example. And so this will cut the minimum depth from 70 centimeters down to 35 centimeters. Let me run this. I just type out the command for it. Stand by.
Okay.
It's always harder to type commands when you're doing a live demo. All right, here we go. So now I'll share this screen. And so you'll see in the same environment. So now you can kind of see where previously my hand was going to invalid depth. Now I can get a lot closer. So now it's 35 centimeters. And there's an additional configuration. So this is with 640 by 400 depth resolution. And if you enable extended disparity, you can get to the same 35 centimeter minimum depth at 1280 by 800. And if you do both 640 by 400 resolution and extended disparity, then the minimum depth is actually determined by the focal focal distance of the cameras. So it's 19.6 centimeters is the minimum distance for the grayscale. So long story short, 19.6 centimeters to, let's say, it really is application dependent on your max range. Let's say there's a hard ceiling of maybe 20 or 30 meters or something like that is the maximum distance you'd be able to perceive.
Great. The next question is, what is the frame rate of the depth camera?
Yeah, so the default frame rate is 30 frames per second, but it can theoretically go faster than that. I don't immediately recall what we support. I think we support 60. I could probably try it real quick, but eventually we'll support 120. So the cameras themselves are capable of doing 120 frames per second at 1280 by 800. But I think we only support to 60 right now, but the demo that I'm running right now is 30 frames per second.
What about the field of view of the camera? That's another question.
Yeah, so that one actually has a bifurcated answer. So the unit that you receive, this is the standard OAK-D, has a field of view of it's 83 degrees diagonal for the grayscale and 81 for the RGB. That's the diagonal, so they're about 70 degrees horizontal. But one of the great things is it is modular and open source hardware. So a variety of companies have just taken this, which is the core that runs all the firmware and works with all the open source software and so forth, and then produced modules with, actually on my desk here, with M12. So you could even produce your own boards. So you can get any field of view you want. And we support mesh calibration, which means you can do fisheye as well. So you could do like 180-degree fisheye and get a depth result for the overlapped field of view of those fisheye. So default is around 80 diagonal, around 70 horizontal. But you could buy cameras from Arducam, for example. They sell this one, and they've made it specifically for Oak. And then we have these. Let's see if I have more of them on my desk. I do. Yeah. So we also have variants of the kit like this. I mounted to a piece of wood. But if you want a different stereo baseline, so this is about double the stereo baseline of a standard Oak. So you can see here. And then you could use different cameras and then also double the baseline, or even further, you could do a couple foot baseline with longer FFCs. And so you can do very long distance with that. Like this one would probably be able to do, I don't know, 55 or 60 meters or something. So you can modify the field of view because it's open source hardware, buy cameras from Arducam. And then, this is just the plug-in with 70-degree horizontal.
Yeah, so we are getting a lot of questions, so I have to select. Unfortunately, I can't go serially. I'll select the questions which are most relevant. So one of the questions is OAK-D wireless? Is Wi-Fi included?
So this one does not have Wi-Fi. We have a variant that we keep stocking out of. So I actually shipped the last one from my desk, but there's a PCB only variant that's a bit smaller than this guy, but with an onboard camera. This is a power over Ethernet variant that does have an ESP32 on board. So the idea with that is to allow the capability to do like AI of things sort of application, where you use it as a sensor, you produce metadata like, is there a fire? Is someone injured? Are they wearing their hard hats? Where are people? Are they social distancing? And you can pack that all into like a single byte even, because that was only 5 things. So it fit very well into one hot encoding in a single byte. And you can send that over Wi-Fi or a cell connection or what have you. So we do have one of those. The standard OAK-D is not Wi-Fi, but you can use it with a Pi Zero, for example. So one of the core bits of this is this does all of the CV processing and all of the AI and all of the spatial aspects. And so you can literally just get metadata out. So that allows you to, for example, you could record 4K video off of this and encoded grayscale streams to a Pi Zero, which would otherwise be impossible because this does all the encoding for you. So it's only 3 megabytes a second going to a Pi Zero. So if you wanted to do Wi-Fi with a standard OAK-D, the easiest thing would probably use a Pi Zero or something else that has onboard Wi-Fi and just connect it over USB.
Yeah, and in case some people, it's not clear to some people, this camera does require a host. So you have to connect it to a computer or say a Raspberry Pi or some host. This doesn't work in standalone mode. For the competition, that's very important. And also for the competition, this Wi-Fi would not be included. You would have to connect it to a host. And on the host, you can have Wi-Fi, obviously. So for example, if you're connecting it to a Raspberry Pi with Wi-Fi, yes, then it gets that information, right?
Yeah, and so yeah, the standard unit is a USB connection to some host. It's kind of like the get up and going really quick variant, but there are others, should your project necessitate it, you want to go further with this, that have Wi-Fi already that you can purchase, and others that you can embed with no host at all.
Yeah. Paula has some question. She says she's facing some problem with the competition form. We will definitely look into it. And Paula, I have your email address. I'll communicate with you. But I know that we have received several submissions. So, but things can, some things go wrong. Sometimes people, things go out of space and things like that. So we will check and make sure that the form works for everybody. Um,
I see one other question about the Jetson Nano. So yeah, this works with the Nano, and I've used it with the TX2. NVIDIA, as of last week, released a Jetpack version where OpenCV doesn't work on it. so we're debugging that. The default OpenCV is broken on the latest Jetpack, but otherwise, yeah, that's the only hurdle, and that should be resolved by the end of this week. I think probably by NVIDIA or us.
There's another question which is slightly surprising, but if other people are having the same problem, I want to communicate it. So Vikas says that when can we receive the form to fill out for the competition? This was already sent out. When you signed up for the competition, you must have received a form. If you have not, please send us an email at competition@opencv.org, and we will send you the form. So it is competition@opencv.org, and we'll send you the form. A question about power. If it is maximum power draw is 5 watt, why is there a special power adapter? Go ahead, Brandon. I know the answer,
Yeah.
but yeah.
So actually, like most MacBooks up until 2015 will only give 2.5 watts. So even though it's only 5 watts, if you plug it into one of those MacBooks, the Apple's very strict on everything, right? So they will only give exactly 500 milliamps, and it's super well regulated. So then if there's no power adapter, you plug it into one of those USB 2 MacBooks, or actually, I guess it was like 2012 or something, 2011. Then you'll just be confused why it doesn't work. So we wanted the user experience to be clean. And actually, the device will just run off of USB 3, but we don't tell anyone that because we don't want people to plug into a USB that is regulated to 500 milliamps, which is 2.5 watts, and then be stuck and confused and reinstall OpenCV or recompile or something when it just doesn't have enough power. So by including the adapter and not telling anyone the Easter egg that you can just plug it over, power it over USB, then it just completely gets rid of those issues. And then if people do have a USB 3 port, which are rated to 900 milliamps, so they can do close to 5 watts, and we're actually below 5 watts, then it'll just work. So if you want to use it with something that can provide USB 3 spec power, you can. A Pi, for example, can provide USB 3 spec power. Even a Pi 3 can, even though it's only USB 2. But a Pi can only provide 1.2 amps total. So if you're running like an SSD and you're running an OAK-D, you'll want to use the power adapter or like a powered USB hub or something like that.
Yeah, so the short answer is that you can use it if your device host is capable, and we just don't advertise it because people will get confused if their USB is not capable of giving that power. Okay.
Right, and it's internal ideal diode ORed between the USB jack and the power plug and the USB plug. So you can power off either, and if you power off both, then it's whichever is the higher voltage will be used.
Great. Another question is about calibration. When you say that the system is factory calibrated, what does it mean? Are the intrinsics calibrated? Is the stereo depth camera calibrated? What does it mean?
Yeah, that's a great question. So the intrinsics for the left, right, and RGB are calibrated. The RGB is autofocus, so it's calibrated. I think it's some distance, maybe it's like 60 centimeters or something like that. And the extrinsics are also calibrated. So the left to right extrinsics for the grayscale are calibrated, and the RGB to right are calibrated. So that actually allows you, and then stored on the EEPROM on the device. So that means everything is cross-calibrated against everything else. So you can generate, even though it's not directly stored, you can generate a right to left calibration because left to right is calibrated and RGB is to right is calibrated. So you can produce the homography. So yeah, all the intrinsics and all the extrinsics are calibrated. There is an IMU on board, and we intended to calibrate that in the factory, but it is not calibrated so that we could get these out in time. But we'll be providing calibration for the IMU against the cameras as well, probably Q2 this year. So about when you'd be receiving your devices for the competition.
Great. this is an interesting question, and this also helps us, tell you about one feature. The question is, what is the smallest operating distance for the depth perception of specially small objects? So what do you do when the objects are really small for depth perception? Is there something interesting we can use for that kind of application?
Yeah. So for especially small objects, I mean, the smallest depth of perception for especially small objects, the best thing to do is probably the stereo neural inference. So neural networks can be exceptionally good at picking up those objects. So if you train for that object, even though it's tiny, the neural network will pick it up, say train tiny YOLO V3 or maybe a more specialized network, and then run that in parallel on the left and right cameras. And so that's the stereo neural inference mode. So you're not actually using stereo disparity depth. Stereo disparity depth has a hard time with tiny objects because there might be a hole in the depth there. Whereas when you're running two neural networks in parallel, then if those neural networks are trained to pick up those objects well, then you have the disparity from the result of the neural network itself. So even though they're tiny, you can get a great result. So like a neural network that returns single pixel points, like a pose estimator or a feature extractor, would be a great solution there. You run it in parallel on both cameras, and then you'll get the 3D position, even though it's tiny. It can be the size of a pixel or maybe even below a pixel, but still register.
So, question about the range too. So, I think I heard that you can use the camera. So you have three cameras, so you can pair with the RGB with one of the depth, so you can get a smaller baseline. Is this something that you can do to, like, off the shelf, or how's it work?
Yeah, to the RGB to grayscale to do depth instead. So one a user of OakD has started playing with that, has gotten it to run. So to back up a little bit, the whole architecture we called our Gen 2 pipeline builder. The intent of it is to allow folks to modularly connect what they want to anything else they want. So we hadn't thought of supporting the use case of doing depth off of the RGB and grayscale, or at least we hadn't thought to implement it. But one of the customers came to us, just like your question, said, hey, could we implement that? And we were like, well, no, I don't think so. And then one of the engineers was like, well, yeah, no, that's like, we could do that. And he's the same engineer who said, no, you couldn't do it. But like 3 seconds later, he said you could do it. And it's, since everything's a modular node in a pipeline, you can instantiate the color camera node, the grayscale camera node, and then feed that into the depth processing node. And so, yeah, it's doable. There's some calibration aspects that need to be done on that, which we're actually working on right now. So the depth looked pretty terrible the first time we did it, because our calibration routine that we've open sourced is for calibrating, not in that use case. But yeah, I think it's probably this week that will be a readily usable use case that you could just do out of the box.
Mm-hmm. Just to clarify to the audience why that's great, because baseline determine how close you can get close to the camera before the depth just fall apart. So so that's why I think it's a great question itself too, because when you do hand tracking, sometimes you want to be close to it.
Yeah, I also want to make sure that people understand that some of these things that we are talking about, they may not be, when you're submitting an proposal, do not rely on some of these new features that we are talking about, right? The features that we have, for which we have documentation, that's a good, if you go to docs.luxonis.com, you will see the documentation for the Oak device. And that's the thing that you should look at for, what is possible in 3 months, because the proposal will also evaluate whether, these things can be done in 3 months. And if it is, if it is a 10-person team, then okay, fine. It can be very ambitious, but we'll also have to make sure that, what you select is doable, and it's not a new feature that you're counting on, which is not fully implemented and tested.
That's a great point. Yep.
So on docs.luxonis.com, so you can actually scroll through and see the kind of things that are doable, like the motion detection. Here's running a neural network, getting the 3D position, so it's finding my face in 3D. Here's visualization of depth. Here's the stereo neural inference. So it gives you a quick rundown of a lot of the things that are possible. And then also the OpenCV competition winners from the last time will give you a good idea of what features exist. Let's see.
Yeah, actually, it's a good point. Can you explain more about the competition? Because I think a lot of people ask about the competition format, like what is the grade submissions, and then yeah.
Yeah, so let's start by example, and then I'll hand over to you, Satya, to
Yep.
give some of the rules. So we did a much smaller competition last time. One fantastic winner was doing visual assistance for the visually impaired or outright blind. And so he made the system perceive the world and then speak it to you. Okay, you're on a crosswalk, you're getting towards a crosswalk, there's a street sign, there's an object overhead that could get in your way. And then touchless controls, all sorts of really interesting touchless controls, doing palm detection and digit detection, and controlling your stereo just by going like this sort of thing. Parcel classification and dimensioning automatically using depth and AI together, and fully autonomous forklift, which is really neat to see, telling where the pallet is and where the injection points are. A workout monitoring system, and then automatic lawnmower. And there's a whole bunch of others that we share as well that were not winners, but still really interesting. And I'll hand it off to you, Satya, for the format.
Yeah, let's go over a few other questions about the camera itself,
Okay.
and then we can go about the competition. So one question is, oh, I don't see this camera as as a camera, as a webcam on my computer when you plug it in. So the question is, can it actually work as a webcam? And for the competition, what is the state of that?
Yeah, so you could use, it depends, like Zoom has pretty strict security requirements, I think now, because of how much Zoom got hacked. So using like it with Zoom might be problematic because I don't believe you can use virtualized web cameras with Zoom anymore. So it does not work as a webcam by default because there's so many things and so many APIs and flexibility, like I was talking about, or like Raymond asked about being able to run depth between these two cameras and all the variety of outputs and even custom outputs, right? So we have customers who've run neural models that we've never heard of on the device, and they have custom data format outputs where maybe it's a 1280 by 800 image by 70, right? So it's instead of RGB, it's 70 deep as the output because it's specific to their domain. And so UVC, which is a USB video class, which is a webcam, wasn't architected for that, right? It was architected prior to even AI existing. And so there's no realistic way to support all of that flexibility in UVC. Now, all that said, there are use cases where it'd be quite useful to have UVC. So it is on our roadmap, and likely 2 or 3 months we'll have it. So I talked to this Gen 2 pipeline builder, which allows you to put nodes of useful things, whether it's an AI model or disparity depth calculation or feature tracking or something like that, and then you can tie them together. So one of the nodes we will be implementing is a UVC node. So what that would allow you to do is, when I showed like face tracking or person tracking and depth, you'd be able to run a neural model and then take the output, the region of interest, and feed that into the UVC node. And then that tracking, say it's like automated, digital hand tilt zoom, because it's 12 megapixels, so you can zoom in 12x and still have 720p video. That 720p that's auto tracking and zooming and moving would then be able to show up as a webcam, so that can be used on a system that has no API and maybe only accepts UVC. But that's not implemented yet. What is used is the OpenVINO open source X-Link protocol, which is very flexible and allows all these like variety of data types. So back to what Satya was mentioning, probably don't plan on that functionality of having UVC output, but it is something we plan on implementing, but don't make it critical path to your proposal. And there are ways, if you're wanting to do that, except for with Zoom, to take our output, and we already have wrappers for GStreamer, for example. We have an example, so you can do RTSP. And then there's loopback devices that you can use based on our video output to make it show up as a webcam on your device. Zoom blocks those so that people don't broadcast porn into chats like this. But you can use it for pretty much any other types of applications. So you can make it appear as UVC by doing some host side stuff.
That's great. So Brandon, if you take a moment and go over all the questions related to the device. There are
Sure.
a bunch of questions in Oak while I explain the details about the competition.
Perfect.
So I've gone through many questions, And there are some competition related questions that I will bundle together and answer in one shot so that we are not going question by question, right? And Brandon can do the same thing, go over the questions while I'm explaining the rules of the competition, etc. So yeah, about the competition. So I've gone through several questions about the competition. And so let me just clarify a few things. Now, the general rules of the competition is that you have to set, there are two phases for the competition. In phase one, you will send a proposal which explains what real world problem are you going to solve using OAK-D if you have one in your hand. And the interesting thing is that because you and your teammates will get, each one will get an OAK-D if you're selected. So your solution doesn't need to be based on a single OAK device. You can use multiple OAK devices. Single OAK device is also fine. Now, the team size, there are two kinds of teams. The first team is a general team, and the second one is a university team. For a general team, you can have up to 4 competitors, but if you want to go solo, that's fine. Yeah, you will, in fact, the person who won the first prize in the last competition did go solo. So if you want to be the only person, that's fine. You also have to select a region from which you would be competing. And if all the participants are from the same region, then it's an easy choice, just select that region. But if the participants are from different region, we'll just, you can pick something which is most representative of your group. But uh, i would I would tell people not to try to hack the system in the sense that, oh, you're in China but you're competing as an African because you think that that would be better or something like that. So stick to where you are located either, or where your team is located. And if there is an ambiguity, do the best reasonable thing. um, the reason we have divided this thing into 6 regions is that we want people to solve regional problems. But that doesn't mean that you have to solve regional problems. You could pick any problem you want. But the competition is organized in such a way that for every region, we will have prizes. So you will be judged within your region. And then there is a global prize also, which you would be judged globally. But let's say stick to phase one first. In phase one, you will send a proposal and you can compete as a general team or a university team. The benefit of a university team is that if you're at a university lab, you can get all your lab mates together, form a team of about 10 people, and compete. You can send 2 proposals per team if you are a university team. And for a general team, we recommend that you stick to just one proposal because put energy and effort into one proposal and try to make it right. There are a lot of prizes. We are going to select 150 general teams and 60 university teams, which is 25 general teams per region. And on the university side, there are 10 university teams per region. So it's a lot compared to last time when we selected 32 teams. Here there are 210 teams. So the chances of your getting selected, if you have a reasonable proposal, is very high. And that's what we wanted to do with this competition. We wanted to get this device in the hands of people around the world, in the first phase at least. And then there is the competition aspect in the second phase. In the proposal, make sure that so one of the questions was that what is the minimum size? The minimum size is 1. You could compete solo. The other question was, about groups of people. What kind of groups can you form? You can form any groups. If you are at a university, you can form a university team and make a bigger team. But if you're at a company, if you just want your friends from different companies, there are no rules against that. You can just pick any team. And in the proposal itself, pick a name for your team. We want some exciting names like that you would like. Pick a region, for example, San Diego Dolphins or something like that, which is exciting. Don't use bad words, obviously, to describe your team. It will, we won't be able to select you if it has, those kinds of words. And then you need to describe a single line title, which kind of summarizes what your project is about. And then the description of the project, what exactly is the problem that you're solving. And if there is a regional problem, give some color to the problem, why the problem is important, because we may not understand the problems of all the the entire world. So give us some color why the problem is important for your local community, and then tell us how you're going to solve the problem, right? Given with OAK-D. So you could have one or more OAK-Ds, and how are you going to solve that particular problem? And finally, you also need to mention the qualifications of your teammates. So if they have done some GitHub, if they have done some projects, it's on GitHub, please point to those projects. If you have experience as part of your company or of some project you have done in Edge AI, that is great. If you have trained, if you have some experience in training AI models, deep learning models, that's a big plus. So all these things, they are very useful. So we want to make sure that whatever you're saying, you have the capability to deliver on that. So pick a team that you feel is will succeed in delivering that. uh, Apart from that, yeah, so the deadline is January 27th for this. Let's pick just midnight Pacific time. And I think you can easily modify your submission even after you have submitted it once. So make sure that you get the things before deadline, even if you need some polish. Make sure that one pass is there, and if you need to resubmit, you can go and resubmit once again. You're allowed to do that. Um, I think I might have answered everything related to the competition that I see over here. There was one question in our region, one country was not properly mentioned. So suppose you don't see your country in one of the regions, pick the closest one or pick the one that you can identify with. Um, there are also questions about the format. The format is a PDF format, and use as much space as necessary, right? If your proposal needs to be explained, keep in mind that we'll be reviewing thousands of applications. So uh, we are not looking for very long essays, but it has to be long enough for us to fully understand how you're going to solve this. So I would say that 5 pages is with images and diagrams, etc. 5 to 6 pages should be sufficient, I think. Brandon, do you remember the from last competition? What was the typical size of the length of submissions? You're on mute.
Yeah, so it varied a lot. One thing that I would mention is, it's a picture is worth 1,000 words, right? In computer vision for a reason. So having images and figures and all of those things, it vastly changes the length of the proposal. And I would not be afraid to put a lot of pictures and figures and so forth in. In fact, in the last competition, there was one team that had no figures, and it seemed good, but it actually ended up losing out to another one in the phase one because the other had fully documented with figures what they're planning to do in kind of the same industry. So with figures, some of them were 10 pages, but let's say 8 of those pages were figures, but that is really valuable to understand what you're actually meaning, and that you put the work in to fully, here is the idea, not just written down, but what we're planning on doing. So I would say if you subtract the figures number out of that, the average length is probably like 3 pages of text. But then with figures, maybe you're looking at like 10 to 15 for those that included a lot of figures. And I would heavily advise to do figures and pictures and sketches of what you're going to build, even if it's a nice hand-drawn sketch. That's valuable to have in there so we can quickly understand what you're talking about, because we'll be reviewing a lot of proposals.
Okay, thanks for clarification. So I misspoke. Without figures, let's say 3 to 4 pages, but with figures, it can be pretty long, 10 to 15 pages. Uh, One other question was, if you are at a university, can you still participate as a general team? Yes, go for it. There is no limitation. University teams, the reason we thought about university teams is because last time there was a university team that competed, but we had to disqualify them because it was a large team of 10 people. And with that, it became unfair that you're competing. We had said that the team should be 4 people, but some of these university projects, very interesting projects, they have large teams, and it would be unfair on that side also to just disqualify them, or not to recognize the contribution of all the people. So that's about university team and a general team. There's another question: what makes for a good proposal? You can, for example, there is this question whether the proposal can be for a very specific industry like construction, and the answer is yes. In fact, we awarded two first prizes in our last competition, and two second prizes. One of the prizes was uh, autom- autonomous forklift, and in this case, the device, it's a very specific industry application, but it was beautifully executed. They had a working version of an autonomous forklift. So OAK-D was deployed on the forklift, and it could navigate autonomously to a pallet, and then put the forks in the pallet and lift it. So that kind of application, which is very industry specific, we encourage that so that people know what are the various kinds of applications. There was another one for strawberry picking. There was another one for sorting packages, you know, based on the size of the package, etc. So we encourage very niche areas also. So don't worry about how specific the problem is. It's all good. Another kind of thing that increases our chances of winning is the depth to which you go to solve the problem. One of the first prize winners was a hand gesture controller, and in that, the person pretty much went over all the different kinds of hand gestures, not just one. I think he implemented 6 or 7 different kinds of hand gestures, 7 different kinds of applications based on different kinds of hand gestures. One was based on, the fingers. One was based on waving the hands. He was turning on lights. He was turning on the music, all kinds of things, right? So go to some depth in the implementation of the project, right? So that's appreciated, and bring some creativity out. If you have a creative solution which surprises us, right? Like the one that Ray came up with, using depth, using two different cameras. It's a hard thing to pull off, but something creative like that, which would surprise us, that's always recommended. So
I'll put
I would
one
like
word
to.
on competition too. I really resonate on competition. So my life, I've been doing competition for Intel right now. I really think what you mentioned is document a lot, like make videos of everything you do, and then the process of getting to the answer is very important to a lot of, like, when we look at participants, is how you get to the solution is also very very important. Because I think the last winner, I look at it, most of them are prototype, right? He try, but he makes sure to document, and then now we understand your thinking process, and your thinking process is the golden part to become a winner here.
Yeah, yeah, and the important thing, is to build something. It is very important that it is not just for theoretical. It has to have some practical, real world problem that you're solving. Now I want to switch back to Brandon. I think you might have a list of questions that you can
Yep.
answer in one summary.
Yeah. So there's a whole bunch. There's one on the IMU. We're using the CEVA. It's the BNO 085. It's quite a nice IMU. Skeletal pose is possible. I posted It's actually a default example, so it's just a command line argument in our demo script. Usable distance, to summarize that, the standard is 70 centimeters. So if, you have 70 centimeters, it's going to be what you'll see depth fall apart below that. You can cut the resolution in half, and that cuts the depth minimum distance in half to get to 35 centimeters. And you can do extended disparity, which also cuts it in half. So if you do either of those, that brings it from 70 to 35 centimeters. If you do both, then theoretically it'd be like 17, but it's actually 19.6 because that's the focal distance of the cameras. That's the minimum focal distance of the grayscale. The RGB is closer, it's 8.5 centimeters. Seeing a landscape, so like really far out depth, you would not be able to do that with the standard OAK-D. But if you really want to do the project and you want to see that happen, we do have these, but these are not standard part of the competition. But you could do a variable baseline, a really wide baseline, for example, several feet, and then likely you'd be able to perceive a landscape, but we've never tried. Edge device, yeah. So this by itself is an edge device in the way that it plugs into some small thing like a Pi zero. So it's like definition of edge. And again, if you wanted to go pure embedded, say with Arduino, which is another question, you could. We have a C++ Python library, and you could do that. And C, for example, and already works with ESP32, which can run Arduino. This device is, like I mentioned, just USB 3. So there's a question on that. The latency of this device from photons hitting it to you getting results is around 65 milliseconds. Is what we measured, but that's also including the latency of whatever display we were using. So I was using an IMAX, and maybe there's some latency testing there. So it's likely lower than 65 milliseconds. And then it depends on your neural network, right? So some neural networks are really heavy, like full YOLO V3, the latency is going to be quite high because it's a very high network, but mobile net SSD can be pretty low. So your latency can approach that 65 milliseconds. Is it possible to pass data from the host to this device to do processing? So it's got onboard cameras. So, the default mode is ingesting photons and then producing results, right? Spatial AI results. But yeah, the Gen 2 pipeline builder is architected. So anything you can do from the cameras can be done via the USB cable instead from the host. So I posted 2 links in there. So a lot of our examples for a Gen 2 pipeline builder show how to do things like stereo depth, both from the cameras and also from the host. And same for AI, you can do it from the cameras or from the host. And the valuable part there, it actually gets to another question, is how do you quantify, right? So you convert this model to run on the device, and maybe it's only 2 times a year you actually get to see the data that you want to test on, or it's really expensive, but you have a repository on your computer. Then you can shove all that through the device as if it's coming from the cameras and get quantification on maybe hundreds of thousands or millions or billions of images to see how it performs without having to point it at a billion things. So that is possible to bring in data from the host for all the nodes in the Gen 2 pipeline. Another question is, how much load does this actually put on the computer calculating the depth? So this actually has 3 depth engines in it. So there's another question on, is this RealSense based? It's not, but RealSense also uses an older generation of this chip. So they use the D4, which is kind of like a Gen 0. And then one of the RealSense parts uses a Myriad 2, which is Gen 1. And this is Myriad X based, which is Gen 2. So we have the equivalent of 3 Intel D series like stereo depth capability in here. It's like 3 of the D4 chips, in addition to stereo neural inference and just general AI and a whole bunch of other CV functions. And so this all runs on the device with no load to the host. The only load to the host is, are you choosing to display video, for example? Resolution, 12 megapixel on the color, 1 megapixel each on the grayscale, so 1 megapixel depth. And there is the capability to overlay the color onto the depth. So you can get colorized point clouds, for example. I posted the code. We have a whole bunch of repos for various use cases. One of the questions is, do we support a C++ API? Yes, we do. So the standard API actually is C++, and then it has PyBind to run in Python. So both are equally supported. There is no LiDAR, but we plan on eventually doing a LiDAR augmented. The trades there as stereo depth is 1 megapixel, and a LiDAR of the comparable cost is let's say 0.064 megapixel, but it's way more accurate on its depth. Instead of like 3% depth accuracy, it's effectively perfect depth accuracy for
Question
LiDAR.
here: does it work
Yep.
in the dark? That's a question.
This Yeah, this does not work in the dark. These are actually IR blocking cameras, all three of them. But since it is open source hardware, if you wanted to pursue this, say if your team has hardware expertise or you want to buy other variants, you could go buy modules from Arducam. For example, this one is M12. So you can put an M12 lens on there, which is very standard and popular lens. There are probably hundreds of thousands of options. They're all compatible. So you can put an IR passing lens on there, and then you'd have night vision. You can put IR LEDs and have night vision illumination. So it could work in complete darkness. As someone asked, when will 120 frames per second be available? Pictures or it didn't happen, so I'll just share my screen again. So it already is apparently. So that's nice. So I'll stop that one. So you can run, that's at least running 640 by 480 or 640 by 400. OpenCV courses. So we do have quick start courses on this. Actually, Satya, if you don't mind sharing the link on that, or Phil. So there are getting started courses in how to do various things with the hardware. No, there's a question on, do you have to write firmware for this? So the whole idea, the whole premise is, previously you'd have to do this development kit and learn all this stuff and work with a 388 pin BGA and write all the low level firmware to make this happen. But our Gen 2 pipeline builder is us doing that once, ideally doing a great job, so no one ever has to do that again. So you don't have to write firmware. You can just, even now, you can build a visual pipeline. If like, here's a color camera, here's the neural network I want to run, here's like a preview window, and you can do it in a GUI and then get your results visualized. So that's
question there.
Yeah.
Can you recalibrate then? Because now you don't have to write the firmware. What happens if you drop the camera, it's miscalibrated? How can we fix that? That's a question.
Yeah, so we actually open sourced our factory calibration as well. So if you wanted to get super fancy, you can even go buy a robotic arm and factory calibrate it again. But you can also just grab a laptop, put a flat
checkerboard,
display the checkerboard on it, something like this. I actually did a pretty terrible job of taping this. It's wavy, so don't do what I did. Just use a laptop screen instead. And then you just hold it in like 12 positions, and that calibrates both the intrinsics and extrinsics of the camera. But we've yet to have to recalibrate any of these. This one's in an enclosure, so it's even tougher. But I had, before this one was actually physically in an enclosure, I had the bare PCB, and I still didn't have to recalibrate it, even though I would huck it around with me and accidentally pull a cable and shoot it across the room. So you shouldn't have to recalibrate. Can you, in the competition, use other cameras? Like if you wanted to use a thermal alarm, yeah, please do. You can use other solutions. You could, even though you win a device, you could go build your own, right? And modify the hardware since it's open source hardware, or use this and 5 other cameras to do something really cool. So don't feel like you're limited there. Can you use this with an Arduino? Yes, I actually answered that one already. And then, can you connect to an iPad? You cannot. So Apple's very strict with what they allow to connect for their user experience and battery life and all that. The tripod, someone asked where can you buy that? It's been way more popular than we expected. I think we've sold like 600 of them, and we expected to sell 200. And so I think we stocked out yesterday, but we have another 600 or something on order. So on store.opencv.ai, you will be able to buy this tripod. So this is what I've been demoing with. So it's a pretty nifty little thing because it lets you do all sorts of angles. And then these are movable, so you can like attach it to things. So
I fully agree. I built my own, it cost me a lot more money. Yours is a great deal. I have like my own, I built similar. Yeah. I don't know if you see it. There's a great deal you have there, by the way. It's just don't do what I did. It's too expensive what I built.
That's funny. That's what I did before this tripod as well. I have.
Yeah. Yeah, so if people want to get hands-on, you need a ball head and all that. Yeah, exactly. There we go. Yeah. We're same wavelength in some way.
Yeah. So yeah, this is the tripod. It should be back in stock. Several may have already ordered this with our Kickstarter or from the store, but within, I don't know, probably 2 weeks, we'll have them in stock again.
Is that waterproof? Actually, there's another question I saw. Is the camera waterproof at all?
It's not, but we're building a power over Ethernet variant that will be IP67. And then a question on shipping. Yeah, this shipping's a disaster right now. It's a total mess. So the reason it's that is where I think we're actually paying $40 for shipping right now. There's, I think, a Forbes article came out about how international logistics is just falling apart, partially because of Brexit and customs. So any customs that was dealing with the UK now has to redo all their workings with the UK, and so all those customs are getting inundated. So we've had stuff stuck and just having to be relabeled because customs are requiring that now. So that's why shipping's really expensive. We're working to get these on Mauser as well. Actually, they technically are on Mauser if you just search for OpenCV AI kit. But Mauser's having problems with logistics too. So even though this is all going there, it's just not in stock yet. And so we actually intended to not ship internationally from our store and let Mauser do that because they're a lot better at it. Our shipping's $6 instead. But since they don't have it up yet, we said, okay, we don't, if people really want one, we don't want to prevent them from being able to buy it at all. So we put it back on the store, and it's costing us like $40 to ship things. So technically, we're actually losing money on shipping on almost every order. Not a lot, but we're not making money off of you on shipping.
Yeah, we are beyond 1 hour. I want to cover one more important thing about the competition. I forgot to cover this. So some people have asked, does the solution need to be open source? For example, if you're working for a company, they may not let you open source the solution. And we understand that, because there are trade secrets, etc. So you do not need to open source your solution if you don't want to. We encourage you to open source your solution as much as possible so that other people can build on top of it. However, the final is you don't need to open source the solution, but it becomes a little bit harder. We will actually, if we cannot run the code ourselves, we will ask you for more demos. We will, maybe get on a Zoom call with you to check whether this solution works or not. And this is for phase 2. So bear that in mind that if you don't open source the solution, there will be higher scrutiny because we'll have no other way to check, whether it's a legitimate solution. But we do need a video output from you, which you have to, make available. Otherwise, people will not even know what you implemented that won you the prize. So a video demonstration of what you built, that has to be made open for us to be used in, while showing the results and things like that, and even in promotions. So that's something that you have to be aware of. And in the past, what happened last time was one of the companies had some reservations about their video. So they redid their video and they, blanked out the names of some companies that they did not want to, they didn't want that solution to be out there. So you can do that kind of video editing where you remove pieces, confidential information that you don't want to, but we still need a video and something that we can put out in public saying that this is the solution that won and this is what they did, right? And release of code is not necessary. We highly encourage you that you do that. So that's that's pretty much all about the competition. We have a lot other questions. We got about 110 questions, and we have answered many of them, but others are not answered. We will try to answer them in an FAQ. Phil, give us a day or two to put this up to get up on the competition site. So we will put these questions as FAQs, and we will also link to all the specifications of the camera so that you have the basic questions about the camera, the frame rate, and these kinds of things can be answered in the specification. So are there any other questions, Brandon, that you saw that are important for answering? And
I have a
just
maybe.
go.
Yeah, sorry. Go ahead, Brandon. I don't know.
Okay. So on the open source aspect, so I wanted to share a bit more on that too. So there's a ton of value in, even if everything you've done on this is closed source, it's like that famous mathematician thing is, a solution exists. So just having a video that shows that this is now possible is de-risks for so many engineers that are curious about building their thing. And maybe they're not even building the same thing as you, but you show it on a lawnmower and they're like, well, I'll certainly be able to do this now, right? Like, and that's extremely valuable. So that's the main thing that we're looking for here, is that improves the engineering efficiency for a ton of people, even if you haven't open sourced it, but you show with this device, it's now possible. So that's our ask, right? With the competition, is we want to make sure that that value is being added to the world. If you can open source as well, fantastic, because there's even more value there that people can use your code. But even when the code is released, in some cases, maybe the other application is different enough they won't even use it. They just want to know, okay, that's doable. So a lot of the value is just having that video showing what you can do, and kind of describing problems that you had and limitations and how you solved it, sort of thing.
Yeah, the great example is Roger Bannister. The 4-minute mile was considered impossible by humans. And as soon as Roger Bannister broke the 4-minute mile, within 2 months, within 1 year, actually, there were several athletes who beat the 4-minute mile, but for the longest time, because just the fact that it is possible and you see somebody do it, you know that it can be done. And that's something that we want to encourage. So thanks for bringing that up.
So I
Ray,
think,
you had some questions?
yeah. So before we close, people may ask, how can we find Brandon? How can they find Ray? How can we find people here? What's the best way to reach out to us in then moving forward? Emails, Discord, what's the best way?
So the fastest way, and I'll actually drop the link in there, is Discord. So we've now had a variety of folks implement things that we just didn't know were possible. So one example is someone was asking about, well, can I run my custom CV code directly on the camera? And we said, well, no. Or you can maybe use these techniques that are very hard. And one of the users were like, well, technically, you can actually run PyTorch CV code directly on the thing. We said, really? Can you write that up? So the Discord is fantastic for that, because it's this quick communication from folks that otherwise would be siloed, and it allows this kind of like self-selection where we don't have to be the gatekeepers of that knowledge, because clearly our answer was no, even though it was possible. We just weren't aware of it. So there's so many folks working on this platform right now that there are so many solutions that maybe aren't out there. And so our role in that on the Discord is, we'll pay attention to it, we'll help document it, and then we'll feature it. Like we took that and we put it on our FAQ, for example, the excellent blog that Rahul had made showing how to do PyTorch computer vision directly on the camera. So the best is very likely the Discord channel, because it's so active. But there's also support at luxonis.com, and then there's we have forums as well that you can go to. Anything else on that, Satya?
No, that's perfect. I was not 100% sure about the Discord channel, but okay. If our team can handle that, that's the perfect.
Right. So I think Intel, same thing. I also host a Discord channel just for the community. I'll post it here if you want to reach out to the OpenVINO problems. And also we have Intel forums that we actually monitor by our support team. So we're here to support you. I think that's why I'm here today, to make sure that I show my face. If there's a problem, there's a person at least, right? Not like an email that you don't know where it will hit. So again, join our Discord. I think Brandon one, mine, doesn't matter. As long as we're in communication, I'm here to help. Thank you.
We're both in both of them, so
yes, we are. But if you have more OpenVINO specific, put it on my side. So then we will make sure that we respond the right way, because I don't want to push the ball around. We'll capture the ball as well.
That's great.
That's good.
So just to summarize, what we are going to do is the questions that went unanswered, we will put them in an FAQ section in a couple of days. Maybe definitely over the weekend. By the end of the week, we will be able to put these things in an FAQ section. If you did not get the Discord channel link, we are going to put those in there as well. So, and you will also have the recording for this live webinar sent to you. So give us a couple of days for this. We will be there. And if you have any questions, please feel free to ask in the Discord channel. We are there to help you. And that's it. And thank you so much. There were like, I think 270 people at the peak. And even now we have 213 people as I speak. That's great. One other question was, how many people have submitted applications? People are asking. It actually, I don't know for sure right now. I don't know off the top of my head, but just to give you an idea, last competition, we received 235 submissions for only 15 finalists, right? So I won't be surprised if about 1,000 people apply to this competition, but it's still 1 in 5 chance that your team will get selected. So I really encourage you to put together a good team, think about the ideas, put together a compelling proposal, and you will have a very good shot at winning an oak. And also, the first, if you win the first phase, it's you every member receives an OAK-D. You also receive Microsoft Azure credits for training your model. You receive access to Intel Dev Cloud. So all that is great. And the final prizes, in case you do not remember, there are tons of prizes, about 107K in prizes in all. So I wish you all the best for the competition. Surprise us with your creativity. That's it. Thank you.
Amazing.
Thanks,
Thank you
everyone.
so much for your time.
Okay. Bye. Bye, guys.
Bye.